So we'll start the class today. We'll be dealing with the measurement of tooth thickness. But before that, you have to know what is tooth thickness. Already we have defined this, and we'll be just again revising that particular definition. Okay. So the tooth thickness is nothing but it is the length of an arc. That's why you have to. It's not possible to measure it directly. Okay. So it is generally measured at the pitch circle. So already we have already told that whenever you want to measure the tooth thickness, it should be measured at the pitch circle, and it's therefore the pitch line thickness of the tooth. Pitch circle means it is the nothing but it's the pitch line thickness of the tooth. So most of the cases, we can see it is sufficient to measure the chordal thickness. The chordal thickness is enough so that it is a measurement of the tooth thickness by gate tooth 1 year caliper method. The first one. I will just try to see we'll just try to concentrate on the chordal method and the constant chord method only. They are base tangent method also. So where we use the base tangent micrometer or the micrometer with the two wheels at the fixed anvil and the movable anvil, and the measurement by dimension of pins. But out of this, the first three are very important, and in the examination, you may specifically ask, or you have to mention all the four or any two of them, depending upon the marks he allots for that particular question. Okay, so I think it is now clear. So here, the permissible error or the tolerance on the thickness of the tooth. So what is the error or the tolerance? Because for every parameter, just like I'll try to just discuss later, just you try to take the profile into consideration. So we have the profile tolerance error is given by K. K is equal to M plus 0.1 root over dP. The pitch circle, we'll just try to discuss later, but I'm just telling for each and every individual element we are measuring to assess the quality of the gear, we have to know the permissible error or the tolerance. Suppose the tooth thickness is there, it is the tolerance on the thickness of the tooth. So actually it is a variation of the actual thickness of tooth from its theoretical value. Okay. So here the tooth thickness already we have discussed, it is measured at a pitch circle, and that is the pitch line thickness of the tooth. So what is the tooth thickness? It's nothing but it is defined as the length of an arc. So we cannot measure it directly. So we try to first go for the derivation of the chordal thickness, and then try to the formula is there. Then we just try to incorporate the data in that formula, and then try to find out the tooth thickness at the particular chordal addendum. H. It is known as the chordal addendum. That's what we have to discuss today now. Whether it is the gate tooth 1 year caliper method or the constant chord method. So here the difference between the chordal tooth thickness, what we want to measure now, and the circular tooth thickness, it will be very small for gear of small pitch. So you cannot say every gear will be having small pitch. So the tooth thickness measurement is very much important, because most of the gears we manufacture will not undergo checking of all the parameters. So totally already I told you we have to check 9 parameters along with profile and particular pitch runout. In runout we have to check the axial runout, radial runout, and side runout. We have to check the constancy of the gear. We have to check the gear tooth thickness. We have to check the tooth to tooth composite error and total composite error. Totally 9 parameters we have to check. But each and every parameter has its own importance. Already I told you all the 8 parameters out of 9 parameters are good and 1 parameter is not good, we have to go for rejection of the gear which we have manufactured. So there are various methods of measuring the gear tooth thickness. So it is the measurement of tooth thickness by gear tooth 1 year caliper, and the second one is the constant chord method. Third one is the base tangent method, by which we are using the base tangent micrometer. So that's what the two instruments we have discussed. And the fourth one is the measurement by dimension over pins. So that is very important. And the tooth thickness here, you just try to see the figure. This is the W where we want to check as far as the tooth thickness is concerned. So it can be conveniently measured, the first method, the gate tooth 1 year caliper method or the chordal thickness method. We have to, because the gate tooth thickness varies from the tip of the base circle of the tooth. So you have to set a suitable position for the instrument so that it will be capable of measuring the tooth thickness at a specified position. Already I told you, specified position as far as the gears are very important. Suppose you are not checking the gate tooth thickness at the pitch line thickness or at the pitch circle, it's of no use. It's not gate tooth thickness. That means you are checking a vague parameter, not the gate tooth thickness. So further, this arrangement, we have to see that we have to fix that particular position for measuring the gate tooth thickness. That's very important. Just like machine setting, we have to ascertain the position. So that is, and the tooth thickness is generally measured. Again, I'm telling you, it's measured at the pitch circle, not at the base circle. And therefore, it is also known as the pitch line thickness of the tooth. What is the other name for the gate tooth thickness? It is the pitch line thickness of the tooth. So here the gate tooth 1 year has two 1 year scales. Already I told you, we have the horizontal scale to ascertain the width of the tooth and the depth. Here he has given D, but in most of the textbooks it is H. You can just take H or D, but in the ensuing derivations, either you use H or D, because in D he has used an Archetype, in IC Gupta you might have used H, or in other books you might have used H also. So here we have to see that we have to draw the diagram of the gear and try to ascertain the W at the pitch line thickness or the pitch circle. So here the coincident point at this particular is A, and here the center line is E, here it is B, and here it is an arc here. So it is an arc here where it is the chord ADB. Chord is here, it is known as ADB. That's why it's known as the chordal thickness method. So W is a chord ADB. So it's the arc distance. So this particular distance is adjusted on the instrument. So how you adjust that on the instrument? It should be greater than, what is CE here? CE is nothing but the addendum, the radial height from the tip of the tooth to the pitch circle is addendum. So you have to adjust that particular distance, D or H. So here it is D. We'll just try to just say D, and afterwards we can just according to your convenience we can put H also. So there's no hard and fast rule. We have to use only a particular half of it. So this particular CE, this particular D, you have to adjust so that it will be greater than this addendum value. So W is therefore called the chordal thickness or the tooth thickness, and D is known as the chordal addendum. So you just try to see the figure. So considering the figure, so this is the center of curvature this OA is R, and this is the theta he has considered, and this is the pitch circle. So I just try to practice this particular derivations. As far as the gate 2 thickness, already I told you its importance. W is equal to AB. But what is AB? AB is twice AD. Twice AD. But what is angle AOD? Angle AOD is theta. But what is theta? It is going for one revolution of the gate tooth. It is 360 degrees by 4n. So where n is the number of tooth? Here you are considering a particular quarter of a tooth. So you just try to have 360 by 4 n. So you can use n or t, already I told you. So what is W? W is 2AD. But what is AD? AD is AO sin theta. But what is AO? AO is the radius of curvature or radius. So 2R. 2 into R into sine. What is theta? 360 by 4n. So what is n? Already I told you. So and you can represent in terms of module. So module is nothing but it is a pitch circle diameter by number of tooth. But what is pitch circle diameter? Capital D. D is equal to 2R. 2R by n. So what is R here? R is equal to n into m by 2. So slowly you just try to concentrate or get acquainted with this particular definition because it's very important parameter of the gear to assess the quality of the gear, because if the gear to thickness is not maintained properly, already tell you any parameter out of the 9 parameters you can reject the gear. So that is very important. So R is equal to nm by 2. So you substitute the value of R in W. 2 into nm by 2 into sine 360 by n. So you just there itself you can put 90 by n here, so that you can directly substitute in this particular formula or in this particular equation 1, so that you have 2 will get cancelled. W is equal to n into m into sine 90 by n. 90 by n. So you just again consider that particular figure. What is D? D is equal to OC minus OD. OC minus OD. Because you want to get D, D is nothing but CD. But what is this one? OC minus OD. OC minus OD. So just try to see there. And what is OC? OC is equal to, just try to see, what is OC? What is OC? OC is equal to OE plus addendum, chordal addendum. So what is addendum? Addendum you can take as one module. And what is OE? It is the radius from O to E. It is the radius. So OC is equal to R plus M. So again you write R is equal to Nm by 2 plus M. So what is OC? Nm by 2 plus M. So you just try to again consider OD now. But what is OD? OD is equal to R cos theta. From you have to know the trigonometry also, my dear friends. So it is, consider that particular triangle AOD. So that what is R? R here it is OE. So OD is equal to R cos theta. But what is R? R is equal to Nm by 2. So what is theta? It is 360 by 4n, or simply you can directly substitute instead of theta 90 by n. So directly you will get OD is equal to Nm by 2 into cos 90 by n. So what is D here? D is equal to OC. D is equal to OC minus OD. But what is OC? Nm by 2 plus n plus m minus Nm by 2. What is OD? Nm by 2 into cos 90 by n. So you directly take what is the common thing here? It is Nm by 2. Nm by 2. Nm by 2 plus 1. M you can just directly write as 2 into m. So this n by 2 into 2n by n will get cancelled, and you are left with m. So you have taken Nm by 2 as common. So it is in the brackets you will be having 1 plus 2 by n minus cos 90 by n. cos 90 by n. So you have to just concentrate on the trigonometrical relations, and you have to know what are the fundamentals, what is addendum, what is module, what is the radius of curvature. So all these are mathematics. So just try to see, even in design subjects, if you have one, whether it's mechanics or center materials, if you are weak in mathematics, you have to just, we should not tell at 3-2, because you have to know your weakness and try to overcome that weakness. So any error in the outside diameter of the gear, we should be allowed for measuring the tooth thickness. So in the case of helical gears, the above expressions you have to modify. So you have to take into account the change in curvature at the pitch line. So here, because we are not having the helical gears, we are not concentrating much on this particular derivation, this particular one, because you just try to know only up to here. So what is the derivation regarding the chordal to the W or H? You have to concentrate only up to that one. So here, the 1 year method, whatever we are describing, this formula or whatever it is, we are ignoring the backlash. We are ignoring the backlash. So that is maybe a disadvantage. So the above 1 year method is not very satisfactory, because we have to mention the reason also. The 1 year itself, whatever 1 year we are using, is not reliable to close than 0.05 mm. So it is not naturally, in practice, we can measure only up to 25 microns. 25 microns. So that's also there. And because we are dependent on two readings, what are the two readings here? It is the reading on the horizontal 1 year, and also the reading on the vertical 1 year. Vertical 1 year. It will not be like an ordinary 1 year caliper. It will be having horizontal 1 year and the vertical 1 year. So all this are, we have to depend on two 1 year readings, and each one is a function of the other. If you are committing one mistake on the horizontal 1 year, it will reflect on the vertical 1 year. And if you are not setting that particular H or W or D here on the vertical 1 year, it will reflect on the tooth thickness. That's why this is not so accurate when compared to the constant chord method or the base tangent method. So that's very important. So whatever measurements you are doing with the 1 year, you are taking the help of a edge of the measuring jaw, because you have measuring jaws on the 1 year caliper. You are taking the help of this edge of the 1 year caliper. So, and actually, whenever you are measuring the so many components with the 1 year caliper, apart from the gears, or in the industry there may be other components, standard mechanical components, there's a wear and tear of this measuring jaws. So time and again you have to go for calibration. So, and if the jaws are worn out, you will not get correct value of the, you will not get accurate measurement. You will not get accurate measurement. So whenever anybody asks, in the short answer, what is the limitation of the chordal thickness method or the 1 year gate tooth caliper method over this the constant chord method or the base tangent method, you have to mention this. This is not here in the this PPT, so we have to just mention that three reasons. So here, this formula, already I told you, we are not considering the backlash. So on mating gears, that is the pinion and the gear, which are having equal tooth thickness and without addendum modifications, the circular tooth thickness will be equal to half of the circular pitch. Half of the circular pitch. That's why after doing this experiment in the laboratory by using the 1 year gate tooth caliper method or the base tangent micrometer, we'll try to check up the value I've got. which is suppose it is 3.0, 3.03 or 3.05. So we'll see whether giving the standard values, we'll just try to see whether we have that W is equal to half PC. W is equal to half PC. Just try to see that. So that is a very important thing. You have to check. It is a validity check on the calculations. So that is very important. So after getting that value of W in the lab, you have to check like this. So W half PC. Okay. That is very important. Half circular pitch. PC is the circular pitch. And PC cannot be determined directly. You have to know PP. If you know PP and the pressure angle phi, whether it is 14.5 degrees or 20 degrees, you can have that. So the vernier gate tooth caliper will be just like this. It's not clear here, but you just try to see in standard textbooks. You have the diagram. This is the horizontal vernier and the vertical vernier. So that D, whatever D you are calculating or H, you have to set in the vernier caliper, and exactly at the position of the pitch circle, you have to measure the value of W. You have to measure the value of W, which is a formula which is given by dP into sine 90 by n. Okay, so we have that formulas dB into sine 90 by n, where dP is equal to dP cos phi, because PP is equal to PC cos phi, and RB is equal to RC cos phi, the base circle radius RB. So all that will be there, will be derived from that particular formula. PB is equal to PC cos phi, dB is equal to dP cos phi, the base circle diameter, pitch circle diameter, all that. So just try to very important in the problems which you are asking in different competitive exams. So here, what you do, what is the role of the vernier gate tooth caliper? It is used to measure the thickness of the gate teeth exactly at the pitch circle of the pitch line, and that's why it's known as the chordal thickness of the tooth. And it has a distance from the top of the tooth to the chord. We already seen in the diagram, distance from the top of the tooth to the chord, or the tip of the tooth, top of the tooth to the chord. The chord is ADB there. There is an arc distance. It's not a straight line. That's why you cannot measure it directly. So we have to go for this derivation. So all this you have to know. And the addendum is measured by an adjustable tongue. That you have to see how to measure. And we have a slight disturbance in this one. Okay, there's no problem as far as the current has gone for a moment. I think it was disturbed. So the thickness of the tip tooth at the pitch line and the addendum is measured by an adjustable tongue. So here we have in the vernier caliper that particular part. We just try to show in the practice because we have a lab regarding that, this particular gate tooth thickness. So each of which is adjusted independently. So you have to adjust that by adjusting screws on the vernier scales, and you should see the errors are not there. So whenever you are taking any instrument in the metrology lab, you have to see that there are no errors. And if any errors are there, suppose you have a positive error, you have to go for a negative correction. And yeah, if you have a negative error, you have to go for a positive correction. So this method is simple, but inexpensive. You don't have to just incur a capital or for this particular. We just have this particular instrument, and we have to go for the measurement of the gate tooth thickness. However, already I told you we have to go for different settings because there may be variation in a number of teeth as far as the vernier, as far as the gear is concerned, and they will not have the same pitch, and the accuracy this particular accuracy of measurement is dependent upon the least count of the instrument. So you know least count, intermediate stage, you might have studied, is the least possible value that can be measured by this instrument, and least count is 1 MSD minus 1 VSD. You know for the that particular calculations, you know, because they'll be asking in the lab also, because already you are acquainted in the intermediate. You just try to refresh that knowledge regarding least count, because some of the terms, the fundamentals in the first chapter, or because we have just started directly with the limits, widths, and tolerances. Actually, this particular metrology also, if you have two papers, would have included more knowledge regarding the practical aspects, what we are following in the industry. The heart of the industry, the quality control personnel. Because if they are giving wrong directions, the product, or the wrong measurements, not using the instruments properly upon training, then the production people will think that whatever they are producing, they are of quality products. So you have to give the feedback. That's very important. So here already I told you this is a particular limitation, the wearing of the jaws of the vernier caliper. The measuring jaws, they have to be calibrated at regular intervals because they have to maintain that accuracy of the instrument. That's very important. So we'll just try to more. Actually, today I planned for that bass pitch also, because I thought it will be over. But okay, there's no problem. So depending upon this recording only, we'll just try to mention the topics in the Zoom recording. No problem. So we just try to go for bass pitch Monday's class. But as of now, this is the constant chord method. As far as this method is concerned, here we have the chordal thickness and the, so in the above method means in the gate tooth vernier caliper method, the chordal thickness and the chordal addendum are dependent on the number of tooth that you have seen in the formula. And if you want to go for measurement of a large number of gears, because we are taking large number of gears, each gear will have its own pitch. So each gear will have different number of teeth, and this will involve separate calculations for each set of gear. So this is a very laborious process. It's a very difficult process, and it's also time which consumed for these calculations. So here, uh, the constant chord method is a very advantageous method when we try to compare with the vernier gear tooth caliper method, because constant chord of a gear is measured where the tooth flanks, just try to see the tooth flanks means it is the line joining the crest and the root of that particular gear. So this constant chord is measured when the tooth flanks touch the basic rack. This is the basic rack. This is the basic rack. So this is the basic rack. So rack form, we will having a rack form. So it is the rack form we are having, and the teeth of the rack are straight. The teeth of the rack are straight and inclined to the center lines at the pressure angle. You can see here. You can see this. They are inclined to the center lines at the pressure angle. Pressure angle is given by phi. You don't put theta. There's a standard notation for pressure angle. Already I've seen the definition also. So here we have an advantage, because we are not. What is the advantage of the constant chord method? Constant chord method will be measured where the tooth flank touches the flanks of the basic rack. That is very important. This particular parameter is not dependent on the pitch of the tooth, because for large number of gears, each gear will be having different pitch, and each gear will be having a different set of teeth. So here the calculations are lessened. It is not time consuming and laborious. That you can defend. What is the advantage of the constant chord method over the chordal thickness method? So here the teeth of the rack are straight, and whatever this H or D, they are applicable only for straight tooth gears, straight tooths per gear. Okay, just try to remember. So also here the pitch line of the rack, what we are discussing, because exactly at the pitch line we have to measure the gate to thickness. This is tangential to the pitch circle of the gate. Tangential. So you know the words tangent and normal. So you don't have to explain because in EG you might have studied that. And that two thickness of the rack will be along this line is equal to the arc two thickness. Arc two thickness of the gear. Arc two thickness of the gear around a pitch circle. That's very important. There where you have to ascertain the position. So already I told you the position where you are measuring the gate tooth thickness is very important. And here the gate tooth and rack space are in contact. They are in contact in the symmetrical position at the points of contact of the flanks. These are the points of contacts of the flanks. Exactly. So it is D and E here. You just try to see. So just try to see that particular in the diagram. The diagram you have to draw correctly. And here you might have taken another parameter in order to distinguish between W in the chordal thickness method, and here you might have taken another value, that another alphabet G. Already I told you, don't worry about the alphabets. You try to go for standard notations. Okay. So this particular property or this particular principle, what we are telling, because what we are just discussed is nothing but here the gate tooth and the rack space will be are in contact at the symmetrical position at the points of contact of the flank. So the chord is constant here. The chord is constant here. That's why it's known as the constant chord method. And at this particular uh, position, irrespective of the gear of the system, whether it is having similar tooth or a different type of tooth, or whether it is having different type of pitches. So only the pitches will vary in a we can say in a small number of teeth. Here we don't have to, in constant quant method, we don't have to consider we have to, we are considering this position particularly irrespective of the gear of the system, whether it is in mesh with the rack or not. We are just seeing and just trying to go for the calculations of the gate to thickness by adopting this method, constant chord method. So here this measurement is simplified for all number of teeth. Already I told you, for any particular number of teeth, it is valid. So if a involute tooth, because already I told you for the particular profile, we have the involute profile for the gear and the cycloidal also, but cycloidal is for a large number of tooth, and we are not discussing as far as the cycloidal profile here. We are considering only the involute tooth because which are symmetrically enclosed with basic rack form. Already we have seen in the diagram. So it will be observed that for any size of tooth, that is same module, the contact will be at the fixed points. That's what we are told. The contact will be at the fixed points A and B. So you can take this also, but here you can see it is parallel to D. Okay, it is not parallel, but somewhat it is the A and B points you have to consider as the contact points at the flank. Or there are two fixed points at the points A and B there. So the measurement of this particular thickness is known as the constant chord, and AB is known as the constant chord here. AB is known as the constant chord here. So the constant chord, how you define? It is a chord joining the 2 points. What are the 2 points? The 2 fixed points A and B. How you got the 2 fixed points? By having the particular the flank at the junction where the flank touches the basic rack of the system. Those are the 2 fixed points on either side of the gear. So that is how you just try to explain. So AB is a constant chord here, and the constant chord you have to define So these are opposite faces of the tooth. I told on either side of the tooth, or the correct word is the opposite faces of the tooth. So it makes contact with the mating tooth when the center line on the tooth lies on the line of the gate center. That is very important. So that is very important. And here the value of the particular AB, value of AB, whatever AB is there, it is a depth from the tip, depth from the tip. So where it occurs, and you have to calculate it mathematically and verify it by the particular instrument. So this is the D here, from the tip of the tooth to the AB, and here from AB to here it is H. So just try to see in the derivation. So just try to have this O. This is pressure angle. You know what are the other parameters? So the pitch circle, pitch line of the rack, this is the rack form. This is the pitch circle. Exactly, we are measuring the gate tooth thickness, and this is the base circle, which is exactly below the pitch circle, and this is the gate tooth form. This is the gate tooth form. Okay, so just try to practice the diagram once or twice. So don't practice it directly in the examinations, whether it's internal. So that's why we are going to give Monday, by Monday, the first assignment, and all of you have to submit within a week's time. So the advantage of this constant chord method is, irrespective of the number of teeth same module, it is having a constant chord value. Constant chord is the same. So in the figure, we just try to see what is PD. PD is equal to PF. We just try to see the figure. So we have to go for that. So what is PD? PD is equal to, what is PD? This is PD. Okay. PD is equal to PF. So just try to see there. So just try to name the points, the salient points, important points. PD is equal to PF, and PF is nothing but, it's not a straight line, it's an arc, and you have to take that arc as 1/4 of the circular pitch. That arc you have to take as 1/4 PC. But what is PC? PC is equal to pi into m, the product of pi into m, because PC is a per circle diameter, so it is product of pi into m, pi into m. So pi into m and 1/4 pi m. So just try to see that this 1/4 pi m. Okay. So that is, and what is AP? AP is the line of action. What we have discussed while we have discussed the pressure angle. So that line of action is tangential to the base circle. That AP is the line of action, and here angle CAP, just try to see angle CAP will be equal to phi, because the concept of the alternate angles in case of a parallelogram, we just try to take that here the pressure angle is phi, and there also that angle will be equal to phi, that angle CAP. So you try to consider the triangle APD in that particular figure. So what is APD? What is APD? So what is cos phi? Cos phi is adjacent by hypotenuse. What is adjacent side here? It is AP. What is the hypotenuse? It is PD. It is PD. So what is AP? AP is equal to PD into cos phi. What is AP? PD into cos phi. But what is PD? Already I have seen. PD is equal to PF, and PD is equal to half pi m. Half pi m, or pi by 4 m. So PB is pi by 4 m into cos phi. So you have to practice this diagram and trigonometrical relations, and you have to know what you are specifying as far as the trigonometrical relations. My dear friends, I have seen many students, if you are asking what is sine, what is cos, what is tan, still some are giving vague answers, and some are not representing correctly the adjacent and hypotenuse sides. So you just try to consider that particular triangle and try to know according to that particular trigonometrical relations what is adjacent side, what is opposite, and what is hypotenuse. Okay, so you have to know that. Don't think I'm telling seen that in the offline class. So in triangle PAC, so what is AC? Just try to see that particular figure. What is triangle PAC? What is AC is equal to AP cos phi, and cos phi is AC by AP. AC will be the adjacent side and AP will be the hypotenuse there. So just try to see that in the triangle APC, we have that AC is equal to AP cos phi. And what is AP? AP already we have derived in the previous line. What is AP? AP is equal to pi by 4 m into cos phi. Cos phi into cos phi is cos square phi. And because C is a constant part here and it is 2AC, 2AC. So we have considered only half of the chord here in the triangle PAC. We have to take the double. So 2AC, 2 into pi by 4. So it will be pi by 2 into m cos square phi. So here phi is the pressure angle. Phi is the pressure angle. So for helical case, you have to take the helical angle into consideration. Here we are not considering the case for the helical case. You try to practice yourself because this is not there in the syllabus. Because whenever we try to consider the module for the helical case, it's known as the normal module there, and instead of phi, it is known as the phi n, which is known as the phi n is the normal pressure angle. So just try to skip this particular helical part. So, and this the height is nothing but BC is equal to pi by 4 m. Just try to see this particular equation, pi by 4 m or pi m by 4 into sin phi cos phi. So what you do in this particular figure, in order to just simplify this particular term, you try to multiply and divide by 2 here. Multiply and divide by 2 here. So what you will be having? You will be having pi m by 8. Pi m by 8. 2 sin phi cos phi is sin 2 phi. So this is one of the equation. Just try to keep it like that. So here that is the derivation, but here in the actual in the IC Gupta or any other standard books, okay, this is also standard or not RK because when we studied this, only one book was there, RK Jain. So here you have to consider that constant chord method, and you try to just derive as far as this formula is concerned. So this is nothing but, so whenever you have to practice this particular figures, my dear friends, as far as the things are concerned, because only we are having only 4 minutes time, we cannot just discuss the base pitch now. So you just try to again have a look at this constant chord method. So everything is okay. So everything you don't take it for granted because you can just take you can refer any book like IC Gupta or KLR and any other book, but the notations, the standard notations, you have to follow carefully. The standard notations you have to follow carefully. That is the thing you have to consider. So whenever you are considering all this, you have to see that the base pitch measuring instrument tomorrow will just try to check up, and you just try to know the what is the gate tooth thickness. What is the gate tooth thickness? It is the defined as the tooth thickness exactly. You have to measure at the pitch circle, that is at the pitch line circle. So what is the advantage of the constant chord method or the 1 year gate tooth caliper method? We have told because for the this 1 year gate tooth caliper method, we are taking only for a particular number of set of gates which is applicable, and because the H calculations or the W calculations, we have to we have to go for each set of tooth because the set of tooth are not same, and that's why it's a tedious method and a time consuming method. And the 1 year calipers, the measuring jaws will be worn out. That also I told, the calibration you have to do. And because we are having 2 1 years, that is the horizontal 1 year and the vertical 1 year, one is dependent on the another, and the position of this particular is very important. The position how you set by means of the vertical 1 year, and if you set the vertical 1 year height or D exactly at the pitch line, and then you have to measure the W, that is the gate tooth thickness, exactly at the pitch line. That's very important. So time and again I'm repeating, as far as the particular two methods are concerned, they're very important. And in the ensuing discussions, we try to get other methods we'll try to discuss along with the base pitch in Monday's class. And you be careful of the practice of the diagrams, the trigonometrical relations, and whatnot. So already I told you each and every standard notations you have to follow. Suppose for n is n or t, you follow for number of tooth. You follow the chordal addendum as D or H. You just try to see that, because whatever you follow the standard notations, and you have to defend, because in this particular discussions we have gone for two methods, and short answer questions are there. What is the advantage of the constant chord method or the one-year gate tooth caliper method, and what is the limitation of the, and what is the disadvantage of the one-year gate tooth caliper method or the constant chord method? All that you have to say, because whatever accuracy, because the measurements, you have to have accurate measurements, and whenever you are not measuring properly, or whenever you are not handling the instrument properly, because the instrumentation people, the diploma people, they are seen in this industry, they are having 5 years or 10 years, they are constant not moving in one particular company. The management will rely most of them, because BTech people will try to go for 1 year or 3 years, or not more than 3 years. They try to jump. So don't feel shy. I have learned from the diploma people only, as far as the handling of the instruments, the inspection of the tools and dies, whatever. Some of the things I have developed myself based on the knowledge on gauges. So don't feel shy. I even learned from the machine setter, who is not a diploma or an engineer. So at the beginning, you should learn. Beginning, if you try to put in hard work in the industry, after you get into the industry, then you can have some particular knowledge, and you'll be promoted from one designation to another in a small period of time. That's what I want to tell. So I'm stopping my class here, and Monday we'll try to discuss the other parameters. Okay. Thank you for patient listening. I think still not satisfied with the attendance. Thank you.